expression. So this is the complete factorization. This is a difference of two squares, but you got to at least look for the GCF first. Okay, now this one, the next thing we look for, if the leading coefficient is not equal to 1, you're going to do extra x-man. So let's take a look at something like this. Let's take a look at 2x squared plus 13x plus 15. Step number 1, always, always, always look for a GCF. 2, 13, and 15 don't have factors in common, and these don't all contain an x, so there's nothing that I can take out of all three of these terms, so there's no GCF. Number 2, special cases. The first special case we look for is a PST, perfect square trinomial. Has to be a trinomial, which it is. These have to both be square numbers. Well, they're not, so I know already it's not a PST, so I'm not even going to look any further at this special case. My next special case I always look at is dots. Difference of two squares. Difference means we're going to subtract two terms, and both of those terms are going to be square numbers. Well, this isn't two terms, it's three. It's a trinomial instead of a binomial. And these aren't square terms. So it's not a binomial, and these are not square terms. It's not the difference of two squares. So the third thing we're going to look at is if the leading coefficient is not equal to 1, we're going to do what we call extra x-man. Well, my leading coefficient is 2. 2 is not equal to 1. So I guess I'm going to use extra x-man to try and factor this. But remember, I went through all these steps first. So extra x-man works like this. You start out normal x-man, a times c and b. A times c is 30. B is 13. So what two numbers multiplied together equal 30 and added equal 13? Well, let's see. 30 is 30 times 1. It's 15 times 2. It's 6 times 5. It's 3 times 10. Oh boy, I think I got something going on here. 3 times 10 is 30. 3 plus 10 is 13. I think 3 and 10 are my two numbers. Now normally, when I do x-man, I would go straight into my two binomials, but since this is extra x-man, I have an extra step. And here's what we're going to do. We're going to make a Punnett square. And usually I put my binomial factors on the outside and fill up the inside. Well, this time we're going to fill up the inside to help us figure out what our binomial factors are going to be on the outside. So I'm going to take my first term in my trinomial, and it goes in this box right here. So I have to figure out what times what is 2x squared. Then I'm going to take my last term, 15, and I'm going to put it in this box right here. So that would be this times this has to equal 15. Now when I was in high school, I had to do this big old guess and check stuff until I could figure out what worked, but I have a more precise way to show you. We're going to take this, and we're going to put them in these two boxes, and it doesn't matter which one goes where. And we're also going to make this 10x and make this 3x. Always add that variable. So I'm going to put my 10x here, and I'll put my 3x here. Now we got to figure out what our binomials are on the outside that will equal all these terms in here. So what we're going to do is look for GCF going this way and GCFs going this way. And here's what I mean by that. See these arrows going up? Okay, I'm going to go up like this. What's the GCF of 3x and 2x squared? Well, the only thing that these have in common is an x, so that's going to go right there. Now, I have another up arrow, so I'm going to go like this. and the GCF of 15 and 10 is 5. So I'm going to put a 5 right here. Now, see these arrows going this way? I'm going to find the GCF here. 2 and 10 have a factor in common of 2, and x squared and x have a factor in common of x. And one more arrow going this way, 3x and 15 have a common factor of 3. Let's see how that worked out. Let's multiply those two binomials together and see what happens. 2x times x is 2x squared. 2x times 5 is 10x. X times 3 is 3x. And 3 times 5 is 15. Okay, this works for what's in our box. Let's see. We have 2x squared. Boom. I can combine these because they're like terms, and when I combine them I get 13x's. Boom. And my final term is 15. Boom. We just factored a polynomial that has a leading coefficient that's not equal to 1. And remember, you always have to consider the first few steps. Does it have a GCF? This one did not. Was it a special case? This one was not a PST, and it was not dots. So the next step, the leading coefficient was equal to 1. Yep. So we factored it using extra X-man, and it's X-man with this extra step. Now if you didn't catch that, back up the video and watch it again. Okay, next example is x squared plus 7x plus 10. This is going to be a piece of cake. Okay, GCF? No. Special case? Not a perfect square trinomial. These aren't square terms. Not dots because it's a trinomial, not a binomial. So it's neither one of those. The leading coefficient is 1. So this doesn't apply. Leading coefficient is 1. We're going to do plain old X-man, which we know very well. A times C is 10. B is 7. Your two numbers are 5 and 2. 5 times 2 is 10. 5 plus 2 is 7. Your two binomials are x plus 5, x plus 2. Boom, we're done. You want to verify that with the Punnett square? That would be a fabulous idea. And also remember, if you go through all this and you can't do any of that, not all polynomials are factorable.